Okay, so we're going for the owner of small clothes shop records the number of customers she has during a typical 6-day week in June. The number of customers each day were 15, 12, 15, 14, 21, 31. Okay, so what we need to do is we need to calculate the mean number of customers per day. So to do that, what we're going to do is we're going to go to mode, stat mode, we're going to go one variable. Okay, so on Monday there was 15, Tuesday there was 12, Wednesday there was 15, Thursday there was 14, Friday there was 21, and Saturday there was 31. Okay. Now what we're going to do is we're going to get the mean of customers per day. So that was the average, so x bar number 2, and we get 18. X equals 18. Calculate sigma, the standard deviation correct to one decimal place. So standard deviation correct to one decimal place, we go shift, stat, variable, number 3, and we get 6.43. Once it's to one decimal place, so 6.4. Sigma equals 6.4. Next thing wants we do is calculate the mean plus the standard deviation and the mean minus standard deviation. So once we do 18 plus 6.4 and 18 minus 6.4. So the first answer is going to be 24.4 and the second answer is going to be 11.6. How many days are within one standard deviation of the mean? So how many days were in between 11.6 and 24.4? Well, Monday was, Tuesday was, Wednesday was, Thursday was, Friday was, basically every day but Saturday. So 5 out of the 6 days, is that right? 5 out of 6 days, or 5 days. Okay. Now, on what percentage of the days was the number of customers within plus or one standard deviation of the mean? Well, it's going to be 5/6 multiplied by 100, which will get us, just get off stat mode for a second, 5/6 multiplied by 100 over 1, that will give me 83.33%. Now, what happens next is later during the week July, the customers' numbers were 17, 14, 17, 16, 23, 33. Notice that there are 2 customers each day compared to the previous week. Write down the mean number of customers for July week. Well, I'm expecting the mean to go up by 2 because it says there's 2 more each day, so we'll find out. So I'm predicting the mean of 20 for this one, okay? So once again, go in to your one variable. So we're going to have 17, 14, 17, 16, 23, 33. Okay. Shift, stat, variable. So we're going to get a mean of 20. Mean of 20. Okay. So we're going to get x bar equals 20 as predicted. So the mean went up, but has this deviation? Now that's the question we must ask, right? So go for standard deviation. Standard deviation is still 6.43. So basically, if you increase everybody by the same amount, the standard deviation doesn't go up. Okay? But if they increase by different amounts, the standard deviation does get changed. So it depends on if everything gets affected the same way, it doesn't go up. That's when you add it. Okay. Now, just for our sake, if I multiply everything by 2, so I get 34, 28, 34, 32, 46, 66. I'm going to be doubling the mean, and let's see what happens to the standard deviation. So I'm just going to enter in another bunch of numbers. Now this question I'm doing here is just completely off the beaten track, and it's for anybody looking to really understand what I'm talking about. 32, 46 and 66. Okay, Now what happens here is shift, stat, variable. Now we go for the mean starting off. The mean is 40. By doubling every number, I double the mean. And let's check out the standard deviation. I've actually doubled the standard deviation. So when I multiply each number by a certain factor, I actually double the standard deviation to 12.86, and I also double the mean. So long story short, when you add the same amount to each one, you don't change the standard deviation, but you change the mean. When you multiply it by a certain number, you multiply the standard deviation by that number, and you also multiply the mean by that number. Okay, next one. The distribution of ages at a meeting is shown in the histogram. Okay, so what we're looking at here, the histogram is broken up into 1, 2, 3, 4 slots, so it's gone up in fives. Okay, so number of people from 0 to 10 is 5. 10 to 20 is going to be 10. 30 to 40. Well, we can see that 30 to 40, if we'll just lean it across here, it's going to be 50 people. 40 to 50, 25 people, and 50 to 60, 20 people. Okay, how many people were at the meeting? Well, just need to add all them together. So it's just going to be very much 5 plus 10 plus 60 plus 50 plus 45 is 170 people at the meeting. Okay, now what it says is, given that the distribution has a mean of 43 years and a standard deviation of 15 years, mark on the histogram where the mean minus the standard deviation is and where the mean plus the standard deviation is. So 43 plus 15 is 58. Okay, so 58, and 43 minus 15 is 28. Okay, so I have to mark 58 and 28 on the graph. (58) and 28. Okay, so 28 is about here. 58 about here. Okay. Hence, estimate the number of people in between 28 and 58. Okay, so I have to estimate the number of people in between 28 and 58. Okay, well, to make a start on it, the number of people in the red rectangle. Okay, so basically in the red rectangle there's going to be 50 people. In the blue rectangle, which is 40 to 50, there's 25 people. Now the problem is with the, we'll call it the purple rectangle, is there was meant to be 20 people, but we haven't got the full portion of 20. Now if we zoom in here, okay, what we have is a block, and it's usually 10 across, okay, and when you have the full 10 across, you have 20 people. But we don't have 10 across, we go to 58. So we basically have 8/10 of the people, because we have 8 out of 10. So it's going to be 8 out of 10 multiplied by 20, which is 16 people. So this block here contains 16 people. Okay. Likewise, in the black, this rectangle here usually contains 60 people, but it doesn't contain 60 people anymore, because that's for a base of 10. We now have a base of 2. So now we have 2 out of 10. We have 1/5 of the population in that rectangle. So it's going to be 2 out of 10 multiplied by 60, which is going to be 12 people. So we're going to have, our answer is going to be 12 plus 50 plus 25 plus 16. That's going to be 41 plus 50 is 91. 91 plus 12 is 103 people. There's 103 people in the entire region. If I was asked what percentage of people I have to do 103 divided by 170 multiplied by 100 to find the percentage. So 103 divided by 170, multiply your answer by 100, and the answer would be 60.6%. So they can just ask you different variations of the same question there. Okay, next one. The claims made against the insurance company in a certain year is shown in the histogram. Okay, so what we're looking at here is, we know that this here is 42. Okay, so we might have to just try and make this diagram as big as possible. Okay, so that's a bit more accurate now. Okay, so what we're going to have here is 2, 3, 1, 2, 3, 1, 2, 3. Okay, so that will be 1, 2, 3, 4, 22.5, 3 small blocks. That's going to be 24. Okay, and this one here is going to be just over halfway, so that would be 15. It's going to be 16. Okay, 16. This one here, which is the third one, is 42. Makes this one 40. And then the bottom one here, if we go all the way across, is going to be 12. Okay. So here are our numbers now. Okay, so 24, 16, 42, 24, 16, 42, 40, and 12. In which interval does the median lie? Now the thing I remembered about the median is, if you have an even number of people, or sorry, an odd amount of people, the median is the middle two people. When you have an odd amount of people, like the number 3, the middle is the middle person. So what we got to do is we got to add them all up together. So we get 24 plus 16 plus 42 plus 40, and then plus 12, and we get 134. Divide 134 by 2. Now 134 is an even number, which means there's 2 people in the middle. It's going to be the 67th and 68th person. 67 and 68. Now where are 67 and 68 located? Well, the first 24 are in 0 to 20. The next 16 is in 20 to 40. So 40 people are in this zone back here. And the next 42, so you're talking about the 40th person to the 82nd person, is in between 40 to 60. So the answer is going to be 40 to 60. Taking the mid-interval values of the median score in euro, find an estimate for the total amount paid out by the company in the year. Okay, so it wants the total amount paid. Now, the total amount is going to be, if you remember correctly, what it's going to be is take the middle value in each term. So 10, 30, 50. You add them together and divide by 2. We got 70 there. We got 90 here. So total amount is going to be, now remember, this is going to be in the thousands, okay? So it's going to be 10 by 24 plus 30 by 16, because 16 claims by 30,000. 50 claims by 42, not 45, 42, plus 70 claims by 40, plus 90 claims by 12. Okay, add them all together, we get 240 plus 480 plus 50 by 42, and then the next one's going to be plus 70 by 40, plus 90 by 12. And that is 6,700. So it's going to be 6,700 thousandths. So we got to add on 3 zeros. 1, 2, 3. This is going to be 6,700,000 in claims. Okay. What I'm also going to add on is a question here. Find the mean. The mean is simply going to be all of these added together. Your total amount divided by your total claims. Total claims is going to be 40, 82, 122, 134. It's going to be 134 claims in total. Okay, so 6,700, we're going to multiply that by 1,000. That's how much money we're talking about. Then we're going to divide it by 134. And this means the mean is going to be 50,000 euro. 50,000 euro is the mean claim. Okay, that's if you're asked for the mean claim. Okay, answer for this question is 6,700,000. Okay, next question. So what this question is going to say is express as one fraction in its lowest terms. So I got to do with this is I got to look at them and I got to factorize where necessary. So 5 over 2x minus 3 factorized there, we're going to get x bracket 2x minus 3, and finally 1 over x. Now the highest common factor, okay, is this one here, because what we can do is if we multiply the top and bottom by the same number as I'm doing here, we're not affecting the value of this fraction here. And I can do the same thing over here by adding x top and bottom, and now all of a sudden all the fractions have the same denominator. So what I can now do is I can say it's going to be 5x minus 3 multiplying by minus 1, I'm going to get minus 2x minus plus 3, and that's all going to be divided by x into 2x minus 3. See what happens here, we're going to get a 3x divided by x, because the minus 3 and the plus 3 cancel. We're going to get 3x into 2x minus 3. Now it's 3 multiplied by x, and on the bottom it's x multiplied by 2x minus 3. Because they're both multiplications of x, we can cancel them, and we're going to get 3 over 2x minus 3. Okay, so that concludes that one there. Okay, next one is going to be express this as a fraction in its lowest terms as well. Okay, so what we can do with this one, same type of question. What we can do here is we can do 1 over x minus 1 plus x minus 1 all over 1, just group it together, minus 1 over 1 minus x. Now there's a trick to this one. This looks very similar to this one here. So if I have 1 over 1 minus x, I'm allowed to multiply the top and bottom by minus 1 and change the way it looks, okay? So I'm going to get minus 1 over 1 plus x. So minus 1 over 1 plus x, okay? So what I can do here is I can change this one into 1 over, this is going to be, sorry, excuse me, it's going to be 1 over x minus 1 plus x minus 1 over 1, and then it's going to be minus bracket minus 1 over 1 plus x. The two minuses here, they're going to make a plus. So what I can do here is, because when you multiply them in, when you usually have a -1 in here, so -1 by -1 is going to make a +1. So you're better off just getting rid of the brackets and the negative sign and just making it a plus. And what happens next is, when I multiplied that by -1, sorry, I made a quick mistake here. When I multiply that by -1, it's going to turn into -1 plus x, which is x minus 1. So there's a reason why I did that, was to turn it into exactly the same as this. Now that the denominators are the same, what I can do is I can multiply this top and bottom. Now everything is x minus 1. So it's going to be x minus 1 bracket 1 plus x minus 1, x minus 1 plus 1. So we get 1 plus x squared minus 2x plus 1 all over x minus 1. And what I'm going to get here is x squared minus 2x plus 3 all over x minus 1. I can factorize this here, and when I factorize this I get x minus 2 x minus 1 all over x minus 1. The two of them will cancel, giving me an answer of x minus 2. Okay, next question. Show that 1 over a plus 1 over b is greater than or equal to 4 over a plus b. So we know that a and b are positive numbers. This means we can cross multiply them without affecting the balance. Okay, so do 3 lines on the left, 1, 2, 3. So we're going to get is b plus a all over ab greater than or equal to 4 over a plus b. Now because we're guaranteed that a plus b is positive, okay, I can change b plus a into a plus b, because it's the same thing. 2 plus 3 equals 3 plus 2. We're going to cross multiply, and what we get is a plus b squared, or a plus b multiplied by a plus b. And on the other side we're going to get greater than or equal to 4ab. Multiply them out, we get a squared plus ab plus ab plus b squared greater than or equal to 4ab. This here is going to be 2ab. Bring over this and you get minus 4ab. 2ab minus 4ab minus 2ab. We get a squared minus 2ab plus b squared greater than or equal to 0. And when we factorize this, okay, what you can do is, for perfect squares, just split the middle one in half, and you can use basically the reference number method then to factorize it. So you're going to get a into a minus b into a minus b greater than or equal to 0. And then what we can get here is a minus b greater than or equal to 0. And finally what we're going to get is a minus b greater than or equal to 0. It doesn't matter if b is bigger than a, because it's a perfect square and all perfect squares are greater than or equal to 0. Okay? Alright guys, next one. This one here, okay? Once again, p and q are positive numbers, not equal, greater than 0. So what we're going to do is just going to multiply this one out. We're going to get pq. We're going to get p over p, which is 1. We're going to get q over q, which is 1. And then we're going to multiply that 1 over q by 1 over p. It's going to get me 1 over pq. It's going to be less than or equal to, once again, p and q. On this side, p multiplied by 1 over q is going to be p over q. Then we're going to get 1 over p multiplied by q, which is going to be q over p. And then 1 over p by 1 over q is going to be 1 over pq. Okay, let's cancel what they have in common on both sides. This one here, and now we get 2 is less than or equal to p plus q. over q plus p. Do your 3 lines. 1, 2, 3. 2 is less than or equal to p squared plus q squared divided by qp. Cross multiply the qp. We're allowed to do this because q and p are both guaranteed to be positive. 2qp is less than p squared plus q squared. Bring the qp to 2qp over the other side. We're going to get p squared minus 2qp. 0 is less than or equal to p squared minus 2qp plus q squared. Switch it around. P squared minus 2qp or pq plus q squared is greater than or equal to 0. Split it in half, like I told you how to do this. And then what you can do is you can get p into p minus q minus q into p minus q greater than or equal to 0. And then you're going to get p minus q, and that in turn is going to be p minus q squared greater than or equal to 0. Perfect square greater than or equal to 0. Okay, next one. Now this one here, okay. Now here's a hint. If there ever was a hint, here's a hint. This question can be written like this. And basically what I'm trying to say is that there's 2 ways of writing this question. This can be u of n plus 2 minus 7 u of n plus 1 plus 12 u of n. That is a hint, okay? This question is the same as this question here. Exactly the same. Okay? So what I'm going to do now is I'm going to find out what f of n plus 2 is. Okay? To get f of n plus 2, or if I was getting u of n plus 2, I simply replace, that could be u of n, but it's not in this question. I simply, anywhere I see n, I replace it with n plus 2. So I'm going to get p times 3n plus 2 plus q into 4n plus 2. I'm going to separate them out. I'm going to go p, this is going to be 3 squared by 3n. This is going to be plus q times 4 squared 4n. And then what we're going to get is, this is going to be a 9. This is going to be 16. And then we're going to have 9p 3 to the power of n plus 16q 4 to the power of n. What happens next is we're doing f of n plus 1. Exact same thing as me doing u of n plus 1. Anywhere you see n, replace it with n plus 1. So what we're going to get is p times 3n plus 1 plus q times 3n plus 1. Bring it down. What we're going to get is p times 3 to the power of 1, 3 to the power of n, using the indice rule, plus q times 3 to the power of 1. Oh, sorry, it's not 3 to the power of 1, that one's 4 to the power of 1. Just make sure you don't become complacent, because you don't want to give away easy marks. It's 4. Okay? So that's going to be 4 to the power of 1, 4 to the power of n. And this will become 3p 3 to the n plus 4q 4 to the n. Now, what you want to have here, verify that f of n plus 2 minus 7f of n plus 1 plus 12f of n equals 0. Okay, so I need to get f of n plus 2. I'm sorry, this is, yeah, that's still, this is f of n plus 2, it's this one here. And this is f of n plus 1, which is here. So what we're going to get is 9p, and remember with these ones they can get quite long, so you really want to use all your page, okay? 9p 3 to the n plus 16q 4 to the n minus 7 times bracket f of n plus 1, so it's going to be 3p 3 to the n plus 4q 4 to the n, and then at the very end we're going to have plus 12un, so it's going to be 12 times p 3 to the n plus q 4 to the n, and all this should equal 0. Okay, so let's begin. So what we're going to get is this exact same thing here. We're going to get 9p 3 to the n plus 16q 4 to the n. Now we're going to multiply this in, and we're going to get minus 21p 3 to the n. Remember, you only have to multiply them once. We can't multiply by the 3 to the power n yet because we don't know what it is. Then it's minus 7 times 4 is going to be minus 28q 4 to the n. And then on this one here, it's going to be plus 36p to the 3n. And it's going to be, oh sorry, not plus 36, excuse me, just made a quick mistake there. Plus 12p 3 to the n plus 12q 4 to the n. All this should equal 0. Next thing I need you to do, factorize out the 3 n's, 3 to the power of n, multiply by, now what comes in front of the 3 to the power of n? There's your 9p, there's your minus 21p, and then there's your 12p, and then in front of the 4n, what comes in with the 4n's? Well, they're going to have 16q minus 28q plus 12q all equals 0. And what you'll notice is that the all cancel each other off. You're going to have 3n times 0, because 9 plus 12 minus 21, 16 plus 12 minus 28. Okay, and it goes 0 as well. So you now have to prove that they both 3 to the power of n by 0 is 0, 4 to the power of n by 0 is 0, 0 plus 0 equals 0. Okay. Now, what happens next is we're going to have to solve this question here. Solve. Okay. Now, to solve this question here, what we're going to do is we're going to use the log rules. Okay, so this one is a takeaway log rule, so it's going to be, they're both the same base, so it's going to be log over x over 2 equals log 2 1 minus y. Okay, this means that x over 2 equals 1 minus y multiplied by 2, x equals 2 minus 2y. Okay, the next one is going to be and we can bring the 2y over to the other side, and we're going to get x plus 2y equals 2. That is the linear equation. Now this equation here, we're going to multiply them, and we're going to get log to the base 2, x multiplied by x, it's going to be x multiplied by x plus 2y because it's the multiplication rule, and we're going to get x squared plus 2xy, and that equals 3. Now remember, this is the power number, this is the base number, so we're going to get x squared plus 2xy equals 2 to the power 3. X squared plus 2xy equals 8. Now what we need to do is this the linear, this the quadratic, sub the linear into the quadratic. Well, we already have x on its own as 2 minus 2y, so let's use that. So we're going to get 2 minus 2y squared plus 2 times 2 minus 2y times y equals 8. Multiply it out. It's going to be 2 minus 2y by 2 minus 2y. When we multiply this out, we're going to get a 4 minus 4y minus another 4y plus 4y squared. I want to bring the y here because it's being multiplied. I'm going to bring the y here and slot it in here. And then I'm going to do 2y by 2 is 4y. 2y by minus 2y is minus 4y squared. And then we're going to leave the 8 on the other side for the time being because I think they're going to cancel. So we're going to get 4y squared, cancel with 4y squared. Plus 4y, cancel with minus 4y. Bring the 4 over the other side, comes minus 4. We're going to get minus 4y equals 4. Y therefore equals 4 divided by minus 4. Y equals 1. Now if y equals 1, we have to figure out what x is. Well, we know that x is 2 minus 2y. It's going to be 2 minus 2 times 1. 2 minus 2 equals 0. X equals 0. Y equals 1. Okay? X equals 0. Y equals 1. Next question. I'm going to try to solve this. Now, solving these ones requires a change of base formula, okay? Now, let me see. Log b to the base a is the same thing as log b to the base c, log a to the base c. That's basically what we're using here. Or, there's another one where you can use log b to the base a is the same thing as 1 over log a to the base b. Now let me explain. The trick is with this question is don't let x be the base. You can do it, but it takes a bit longer, okay? So what we're going to do is we're going to use the formula for this. We're going to do 4 times, and in brackets we're going to change this base. We're going to do log 2 divided by log x, and we're going to pick a new base. Okay, and the new base we're going to pick is 2. Log 2, 2. And log 2 to the base 2 is 1. So we're going to end up with 4 times 1 over log 2 to the base x. So in effect, the two of these have switched position. Basically, that's where this rule comes from. They switch position. Okay? So it's going to be 1 over log x to the base 2 equals log x to the base 2 plus 3. Next trick, let y equal log x to the base 2. And what happens is you're going to get 4 times 1 over y equals y plus 3. Now 4 times 1 over y is basically 4 over y. Now what we can do is we can just put y's underneath everything. Y squared, y and 3y. And bring the 4 over the other side, cancel off the denominators. And we're going to get y squared plus 3y minus 4 equals 0. We need to factorize this. And when we factorize this, we're going to get y minus y plus 4, y minus 1 equals 0. We're going to get y equals minus 4 and y equals 1. Convert back what y is. Y is log x to the base 2. So log x to the base 2 equals minus 4. And log x to the base 2 equals 1. Well, what this means is x equals, this is the power, this is the base number, so it's 2 to the power minus 4. And this one here is going to be x equals 2 to the power 1. X equals 2, or x equals 1 over 16. Now if you aren't sure about 1 over 16, why don't we just check it at the start? Okay, now remember you can't have a minus log, so let's try this out. I'm saying that x equals 1 over 16. So let's see if it works. Okay, for log, sorry, do this again. It's in the wrong mode, that's why we didn't get the right log mode up. For log to the base 1 over 16, because that's what I'm saying x is. And then that's going to be 2. And the answer for this is minus 1. Minus 1 on the left. Now let's see what happens when we do it here. We go log 2, and we're going to put 1/16 here. And then there's a plus 3 at the end. And look, both answers are minus 1. So I've actually checked out my dubious answer. So you can check your answers at the end of the exam if you have time, and then you can figure out if you're correct or not before you leave the exam. Okay, this is called verifying your answer. Okay, and guys, look, that is the end of our revision for this. So best of luck in your exam, and if you do this once, go over it again a second time on your own, you should be good to go. And I would spell X if it's wrong. Alright.